Today we'll be starting with the concept of correlation. Now, correlation is a very important topic because it comes for pretty good marks and it has a very, as to mention, nice importance in our syllabus. Fine, it will be used in a lot of places also in statistics. So correlation, the base of correlation needs to be a little strong. Fine. Now correlation, what it means is pretty simple. Two variables, how they are related, how they interdepend among each other, this is related through correlation. Suppose we take price, demand. If price is increasing, quite obviously the demand for the commodity will start to go down. Suppose this pen is available for 20 rupees in the market. If I increase the price a lot, then obviously the demand will fall. If I decrease the price a lot, then obviously the demand will increase. Hence, these two things are negatively correlated. If one increases, the other one decreases, or vice versa. This thing is negative correlation. Similarly, if both move in the positive direction or in the same direction, we say it is positively correlated. Suppose with the increase in height increases the foot size. Fine. With increasing long hair goes increase in shampoo. Fine. So these things are positively correlated and there are many things which are negatively correlated. So we have three things that we need to study. One is scatter diagram, Spearman's method, and we have Karl Pearson's method. Fine. Now this is meant for rank correlation and this is coefficient of correlation. Now, scatter diagram is an entirely theoretical concept. This does not require a lot of sums to be done or anything. It represents the correlation graphically, how it should represent on a graph. So it is not that much relevant in the syllabus. It is kind of a brief reading and it is obviously, it has to be present in all the chapters that you are studying, the books you are referring to regarding correlation. Pretty easy to understand, nothing relevant for it to be explained. So we'll directly, now before starting off with rank correlation, you need to have a brief idea about how the correlation thing works. So we'll start off very easy with Karl Pearson's coefficient of correlation. Give this topic a little bit of time. Formulas are pretty easy, the methods vary. So you have to take care. Either mein koi aapko, there are no individual series, discrete series, continuous series. There's just one set of series that you have to calculate. So those things are now gone. The individual discrete things are now gone. We only have two set of observations from which we'll be doing the entire sum. It is very easy. You just need to learn, mug it up rather, the steps that you have to follow. It is very easy, 5 to 10 marks, whatever the weightage is, you can easily gain. So we'll start with Karl Pearson's coefficient of correlation. I'd prefer you write it down. Calculate, do the sum with me. First of all, the formula. Write down the formula for coefficient of correlation. R is equal to summation xy by root over x square fine. Summation xy divided by root over summation x square into summation y square. Now this thing does not give us an appropriate advantage over what is going to happen, so we'll have to directly follow the steps. So we'll start off directly. First write down two series for x and for y. Capital X, capital Y. According to my handwriting, my capital X will be like this, small x would be like this, capital Y like this, small y like this. Just told you so that you do not mess up between capital and small. So capital X, capital Y. Write down a random set of observations: 10, 12, 11, 13, 12, 14, 9, 12, 14, 13. Y, 7, 9, 12, 9, 13, 8, 10, 12, 7, 13. Directly follow the steps. Find out the total of X, total of Y. The first thing that we'll do is find out the arithmetic mean of these two series. The mean, the average of these two series. Calculate the total for X. Coming down to 120. Total for Y. 100. Total set of observations, small n is equal to how much? 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Correct? So arithmetic mean of X is equal to 120 by 10 is equal to 12, and arithmetic mean of Y is equal to 100 by 10 is equal to 10. Correct? So arithmetic mean of X is 12, arithmetic mean of Y is 10. Make a column deviation of X and make a column deviation of Y. Now deviation from X, that is arithmetic mean, and the column of X that we have originally, we'll have to subtract those. So 10 minus 12 gives us minus 2, 12 minus 12, 0, 11 minus 12 minus 1, like this it goes on, 13 minus 12, 1, 0, 2, minus 3, 0, 2, 1. Total of this thing, we'll see, this is not required. X individually is not required, total not required. Start off with Y. The arithmetic mean of Y was 10. 7 minus 10 minus 3, 9 minus 10 minus 1. So X, Y, again this total will not be required. What we require is X, Y. So make a column for X, Y, multiply these two. Minus 2 into minus 3, 6, 0, minus 2, minus 1, 3, 4, minus 4 it will be 0, 0, minus 6, 3. Total of XY, how much? Consider the minus signs also. This is not absolute value. We have to consider the minus signs. Minus 1 into 2, minus 2. You have to keep in mind, otherwise answer will be wrong. This is minus 4. What else do we require? X square, small x square and small y square. So minus 2 into minus 2, 4. All the negatives will be gone. 0, 1, 1, 0. 1 square is 1. So 1, 4, 9, 0, 4, 1. And y square, 9 1 4 1 9 4 0 4 9 9. Give me the total of these two. X square total and y square total, how much? Total of x square is 24. This is 50. So summation x square 24 summation y square 50. So we have the formula here. Summation xy divided by root over summation x square into summation y square. Summation xy is minus 4. Minus 4 divided by root over. How much is summation x square? 24. Root over 24 into root over how much? 50. Gives us how much? Calculate. Use calculators if possible. I've used calculator here, that's why direct method, but you can use the long method also. If you are not permitted to use calculator, I'd recommend you multiply 24 into 50, use the manual method for calculating the roots, factorial methods. Fine. This is basically Karl Pearson's method. Nothing out of this can come from Karl Pearson's method. Fine. I hope this is pretty easy. So you have been given two series x and y, maybe a and b. You'll have to frame it accordingly. So x and y have been given. What you have to do, find the arithmetic mean of those using the individual mean formula for arithmetic mean, then deviate it individually, square it, multiply them, use the formula, you get the answer. Pretty easy. All these calculations are going to be very small, very easy, within your control. The only calculation is the root over thing. You'll have to take care of that. If calculators are allowed, then your problem is solved. If not, then you'll have to take care of calculation purposes, because you'll have to understand how manual calculation for roots have been done. You'll find many videos for manual calculation of square roots. Use those formulas. Fine. This thing is very easy. Karl Pearson's method. Next we'll be starting off with the other method, that is rank correlation. So write down Spearman's rank difference method. Spearman's rank difference method. Now all of us know what the concept of ranks is. How do ranks work? The highest number here will get the first rank and the lowest number will get the lowest rank. So we will be given a set of observations. Now we will not arrange the observations in any order. I have seen people do the mistake to arrange the orders. No, you have to take the sum as given, no ascending, no descending orders to be made. That was what we used to do in median mode maybe, but now we don't need to do anything. No ascending, no descending orders, arrangement is required. Fine. Just go on with the sum as given and we'll find out the ranks. Let's take an example. Very easy. First of all, you can write the formula. That is, rank correlation is equal to 1 minus 6 summation d square by n square minus 1. 1 is outside of this equation. Fine. This is the formula that we'll be using. Write down two series, X and Y. For X, write down 87, 22, 33, 75, 37. Not taking a very big example, easy to understand. For Y, write down 29, 63, 52, 46, 48. Fine. Now we'll have to get the ranks, correct? So we take R1 rank 1 for column X and we take R2 rank 2 for column Y, for X and for Y. Now which is the highest number here? Check for the highest number. 87, rank goes 1. Next is 75, rank is 2. Very easy. Rank is 3 for 37, 33 rank is 4, and for 22 5. Similarly it applies for Y also. Highest number is 63, rank is 1. Next is 52, rank is 2, 48 3, then 4, then 5. Check if right or wrong. Next, R1 minus R2. R1 minus R2. This will give us what? D. So this will be minus 4, 1 minus 5, minus 4, then 4, 4 minus 2, 2, minus 2, 0. Do we require D? No, we require D square. So we'll square 16, 16, 4, 4, 0. Find the total fast. Total is coming down to 40. So summation D square we have 40. Now what is N here? Obviously the number of observations. N is equal to number of observations, no frequency or anything given. So summation D square we have 1 minus 6 into 40 divided by 5 into 5 square minus 1. So we get 240 divided by 5, 25 minus 1. Multiply 24 into 5. Pretty easy. Answer will be minus 1. So this is negative correlation. Now these are the two methods for correlation. That is the most important. Scatter diagram, again, it's a kid's play. So anybody can do it. You can also do it from, it is basically theory based, so it does not require a lot of explanation. You can give it a reading, you'll understand how it is positively correlated, negatively correlated. The first formula is pretty useful for calculating correlation, coefficient of correlation, and this one using through rank method. Fine. Now here there is no conflicts. Fine, no conflicts are there, everything is fine here. But what if I said there is one more number 33 here? Instead of 22 there is 33. Then what would have happened is the ranks would have a conflict, kind of like this. Now these conflicting ranks have another formula, an elongated formula for this method. Now that elongated formula has already been discussed by Amresh sir. I have attached the link. The link is in the description. Go skip forward to that particular portion and you can obviously find the video. This is all that you need to put in mind for completing correlation, nothing else. Fine. Many people mess up correlation with regression. That is completely a different topic. And in 11, 12 and lower classes, you'll only require correlation. Fine. So this is the entire explanation for it. Do not forget the formulas. These are completely different from whatever you have studied, measures of dispersion, whatever you have studied from central tendency, nothing matches from here. So you have to mug up the formulas. These are fresh formulas. Always remember these things, small things like where the square should be placed, where this 1 is, because in the exam you might mess up. You might write it in the numerator and answers might be slightly different. So please take care about that. Rest, this is all what you need to know. And if you like the video, like and subscribe. Stay updated.